Okay, first up, let's do a review of this kind of problem. X squared minus 1 over x plus 1, x plus 5. And that's a function. And Bob can tell us things like y equals whatever, because Bob can tell you y. Do you remember that dumb little way of remembering the, in which asymptote is it if it's a y equals thing? A horizontal, very good. The horizontals are the y ones. So I just want you to be able to know if you see that, like this is an asymptote, y equals 6, then you know it must be a horizontal asymptote. Or if it said x equals 2 was an asymptote, then we'd know it was a vertical asymptote. Okay. Of course, the domain means everything works in the function, or sorry, domain really means what numbers would work in the function. And you always start by saying everything works except whatever makes that equal 0. Okay. And then the last idea is those Bob ones I started with, the y equals things. They're bigger on bottom, bigger on top, or same on both. And in this case, it's a same on both. And therefore, do you remember the rule for same on boths? Yes, sir? Ratio. Yes. It's a ratio of the lead coefficients. So we'd have to figure out the lead coefficient of this one, which really isn't too hard. It's a 1. And then figure out the lead coefficient of the bottom part. And then figure out the answer is y equals that one over the other one. All right. See if you can answer then for me. I just gave you the rough outline on how to do it. The domain, the vertical asymptote, the horizontal asymptote, the holes, and you may not do it in that order. I would start with the domain, and remember, if you can factor, you should. I'm going to pause for a second while you try to answer this one. So let's keep this moving. Domain. It starts with this big all real numbers. Raise your hand if you knew that. Okay, good. Now we write x cannot be this, and typically it cannot be a couple things. All right, x cannot be -1, because if I put in -1, it makes the bottom 0. And it cannot be -5, because if I put in a -5, it will make the bottom 0. The denominator can't be 0, because remember, something like 8 over 0 is called undefined, and it's not allowed. Okay, so this will work everywhere except those two spots. And then this is really important. These two are either holes or vertical asymptotes. The vertical asymptotes come from down here. All right, now, if you didn't factor the top, you would have probably thought they were both vertical asymptotes. But if you factored the top into x plus 1 and x minus 1, like you should have, because that right there factors to that, okay, then I'd see that that cancels that, and that this one must be the hole, and that leaves this one as a vertical asymptote. If you get that part straight, you've got a lot of it figured out. All right, the hole is at -1 then. But we make you figure out where that hole would be located. So I get that there's an empty spot on the graph right there. Exactly where would the empty spot be? Well, you take the -1 and you stick it into not the original function, or it'll just crash. That's the point of a hole, is it crashes the function there. So we got to put it into the resulting function, the stuff that didn't cancel, which is that stuff. And then I put the -1 in there, and I have -1 minus 1, which makes -2, over -1 plus 5, which makes 4, which would make -1/2. So did anybody have -1 comma -1/2? Sweet. A lot of people did. Nice job. How did I do that? Okay. Did you get how I got the -1, that this was a hole because something canceled with that? This part right here canceled. Okay. And then to get the other part of it, I took this and I stuck it into the function. Not the original function, or it would have just crashed. But the resulting function after this and this canceled. What was left? This was left. I'd take and stick -1 into that. Okay, and I end up with -2 on the top and +4 on the bottom, so it makes -1/2. All right, the verticals. Remember, this was the other one was the vertical. X equals -5. And the last thing is the horizontals, and Bob tells you the horizontals. He's the one who will tell you the y. So y equals, bigger on bottom, bigger on top, same on both. By the way, if you cancel something off, you canceled off an equal amount of degree, and therefore you can judge whether it's bigger on bottom, bigger on top, or same on both by looking at the original or the reduced new function, this simplified function. So I'll just look at that one and say, oh, it's same on both. And if it's the same on both, then I just have to do a ratio of the lead coefficients, which are 1 and 1. So y equals 1. How many of you got at least 3 out of 4 of those parts right? Okay, good. So that's the thing you were supposed to learn before the sub got here. Okay, that was stuff I taught you, and covers a lot of topics in there. Now let's talk about what you were supposed to learn yesterday. So if I go to my content and pictures, I can drag out a graph here and say, what if you had to graph this? Not just sketch it, but graph 1 over x plus 4. There's 2 ways you could do this. You could either know what the parent function looks like and then just move it, or you could do this in terms of asymptotes that we just talked about. That would be probably pretty smart. All right, so I'm going to show you a couple different ways you can do this. Also, the XY chart should be your best friend when you're graphing, and it's best to probably just test certain points on that, because otherwise you get weird decimals. All right, so I'm going to show you, how about this? I want to know, what's the way that you were taught yesterday? Did he focus on the XY chart? I'm guessing not. Okay, did he focus on taking the parent one and then moving it? Oh, okay, so then that was me teaching. I think I probably would have used a blend also of a little bit of both, okay? So I'm thinking that I would start by saying, do you know that the parent looks like that and goes through those 2 really important points? You need to know that. The parent function is y equals 1 over x. And this one's just been moved. Which way? 4 to the left. Okay, so if I move this whole thing 4 to the left, by the way, it also has asymptotes in there. I'll put this and this asymptote in there, and I'll move everything 4 to the left. 1, oh, no, don't move that. I'm going to lock that thing in place. And there we go. Now I'm going to go 1, 2, 3, 4, and then I'll move this 1, 2, 3, 4. Move this 1, 2, 3, 4. Better take the line with it. There we go. Now I don't have to move this because it's obviously not going to really change anything, right? Okay, so there it is. Raise your hand if you would have had the same thing. Okay, good. Now what if there was a hole in it? All right, so the hole part really isn't that complicated. That just means that there's something else in the problem, like, for instance, this. X plus 3 and x plus 3. That's tacked on at the end of the equation. Okay, and you get how this part would cancel this part? That creates a hole. Where? Well, we've used that before. We could find out exactly where algebraically, but there's a much easier way. If you just look at x is -3 on your picture, because -3 is the thing that would have been the weakness there. You go to -3, 1, 2, 3. -3 is right there. I follow it up to the graph, and that means that spot that used to be one of our key points is now a hole. There we go. The most common mistake, of course, is kids forget to put the hole in, or they put the hole in the wrong spot. Yes, sir?
We kind of focused more on doing what you taught us before and then taking that information and being able to put it on the graph.
Okay, and that works. That really does. But I like to show you multiple ways to do stuff. So this is a good way to do it. Now, could I also, and I was about to, believe it or not, go and say, okay, so if we had done the domain, that really wouldn't help us very much. But what would help us a lot is the horizontal and the verticals. Okay? So the vertical asymptotes, just to make sure those are in the right spot, and the horizontal asymptotes, the verticals are the ones that come from the bottom. So from the vertical asymptotes, I should have a vertical asymptote at -4, and look at that. I do. It's right there. Okay, and the horizontal asymptote is the one Bob tells you about. Bob tells you why. So if I want looking for the y equals, Bob, is this bigger on bottom? Yeah, it is actually. What's the rule for bigger on bottoms then? Y equals 0. Bob is 0. Okay? Then there's an asymptote at 0. Look at that. It worked. All right. I personally think that you could make the argument that we should just do what we did on the last problem right here and find the domain, the vertical asymptote, and all the holes and stuff, and this part especially. I could just go graph those things. You can do it that way, absolutely. But if you know the parent, it's actually pretty easy to just move the parent over and slap a hole in the right spot. It's not that bad. Yes, sir?
And what if it's bigger on the top and there's no...
No asymptotes? All right. Then if it's bigger on top, I think you're going to understand what I mean here. If it's bigger on top, it's not a fraction anymore. Here's what I mean. X squared over x. That's bigger on top. But do you get that can reduce? And it would just be y equals x. And all of a sudden, it's not a fraction function. Okay? So don't worry. We're not going to try to trick you with something really complicated like graph that. But if I did ask you to graph something like that, that's really complicated, what never fails? Your best friend in graphing. XY chart. You could find something that would work. And it would take you a while, but you just find some stuff that works. You'd know there was a weak spot at what? -4. So you wouldn't even bother. Well, you could put -4 on here and then say hole, or not necessarily a hole. Nothing on top cancels this, so it's probably an asymptote. You know there's an asymptote at x equals -4. That's one of those x ones. So it's a vertical asymptote at negative. And then you could find points. It'd be a pain in the butt, but you could do it. And I'll put in 2 and see what happens. 2 squared is 4. 4 minus 5 is -1. Over 2 plus 4 is 6. -1/6. So 2 goes with -1/6. Over 2, up, down, -1/6. All right. I could put in something. Let's try to be strategic here. I'll say I put in 0. And I get -5/4. That's -1 1/4. So 0 would be -1 1/4 there. It's going down there. If I could just get... My gut says this isn't going to go like that, is it? That doesn't make sense. My gut is it's probably going like that. So remember, you're going to get closer and closer to the asymptote, right? So I think the graph would look something like that, and if I had to find something on the other side, I'd go to like -5 and I'd stick that in and see what happens. 25 minus 5 is 20 over -5 plus -1 makes -20. So at -5, it's -20. It's like way down here. So it's probably going like this. Up here and down here. I'm not sure though. But the point is, if we gave you a really, really nasty function, you can figure it out with an XY chart. But we aren't going to. So you may as well stick to parents. Now that one we wouldn't do. How about this? I could see myself doing that. And then throwing in, just for fun, a hole at x plus 2. All right, now I'd like you to make me a quick graph of that. It's got a hole in it. You should know what the parent looks like. And then you should go, oh, the parent's been moved 3 to the left and blah, blah, blah. Pause for a second while you do this. It really wouldn't be a bad idea to figure out where the horizontal and vertical asymptotes are. Once you know that, you know a lot. I'll pause while you try. So let's see how you did here. First thought, that cancels and it cleans things up a lot. I just got to remember that it canceled, so that made a hole, and I got to remember to graph the hole. Be honest, how many of you remembered the hole? Thank you. Okay, that's almost everybody. Cool. Now I got to know what the parent is. It's got all this distraction stuff, but that's basically a move to the left, and that's a move up. So if I take those out, I'm left with this as my parent function, 1 over x. So that's just basically this guy again. And the asymptotes are still basically there and there again. Okay? Now I'm going to move them. I'm going to move them over. And this one, this plus 3 right here, and the plus 4 means 3 to the left and up 4. Here's 3 to the left. 1, 2, 3 to the left. Moving this over to match. And then up 4. Moving this up 1, 2, 3, 4. And moving this up to match. And moving this up to match. There we go. Now, this one's a little funky because it's actually rising. Didn't want that, so let's make that more. Getting closer and closer, never touching. Okay. And this is the classic part. Kids get this far and they forget. What? The hole. And where's the hole at? -3. No, wait. Where's the hole? -2. Because it's the thing that makes this part 0. -2. So I go to -2. And oh my gosh, it's a lot like that last one, isn't it? Empty spot right there. But just to clarify, that's not like just a special spot. That is a spot that does not exist. It is an empty spot on the graph. It does not have a point there. Because if you put that number into the function, it will fail. Okay. That's what you're supposed to know to this point. All right. And then, what's today? It's officially called, and you looked in the notes, review. So it's a review today, a review assignment, and then a review tomorrow, and then the test is on Friday. Got 2 reviews built into this one. We actually could have easily tested on Thursday, but with me being gone and one of my other colleagues was also sick, we know that you had subs and stuff. We were like, why push it? We'll just put the test on Friday and we'll be fine. Now, anybody who's gone on Friday, if you want to, you could take the test on Thursday. Does anybody know they're going to be gone on Friday? One person, okay. You might want to consider taking it on Thursday. Otherwise, you'll have a 3-day weekend to forget everything. So your choice, but if you take it Thursday morning or after school, you would probably be prepared well enough. Okay? All right, so I've covered a lot, but I didn't cover everything. Let's go over what else could possibly be on this upcoming test. Let me give you an example where instead of telling you, here's the picture, what are the asymptotes, what if I said, here's a bunch of stuff, like the asymptotes are here, and there's a hole here, and there's a root here. What's the answer? Okay? So let me give you one that's fairly, simple. Draw me the picture if the parent is y equals 1 over x, and there's these asymptotes, and I'm not going to tell you which ones they are. You need to figure out which ones are which. There's an asymptote x equals 3, and there's another asymptote at y equals -2. There's a hole at x equals -4. Tell me what the equation was. Not what the picture was. Tell me what the equation was. Of course, it's y equals a big fraction. See if you can figure it out. I'm going to pause for a second. Just to clarify, there are multiple answers for this. Okay, so this hole for sure means we have that and that, because that's how you make a hole, is have something cancel on the top and the bottom. And -4 would go with an x plus 4 factor, if that's the root or the 0. Okay, so now if I'm going to put in the rest of this, asymptote at x equals 3. What does that mean? Bottom one has to have a what? X minus 3. Excellent. Okay, asymptote at 3 would be an x minus 3. Okay? Make sense? Now, how about this y equals -2? That's definitely the hardest part. Y comes from the Bob things, right? Bob, sob, or bot. Talk me through what you thought.
Well, since it's x squared on the bottom, it's going to be bigger on bottom, which makes
If we leave it this way, you're right that the bottom would have a bigger degree, and therefore it's a bigger on bottom.
And then you can just put a negative towards the very end.
You could. You could put a -2 out here. you get how this one would be a bob, and therefore the answer is y equals 0 plus whatever's on the outside. That is a very advanced way to do it. A lot of people would have done it a different way. Who did it a different way? Yes. I'm going to take that negative 2 off of there. What'd you do, sir?
I did negative 2x plus 4.
So you slapped in a negative 2 in here?
Or no, in parentheses.
Okay.
So it was the same on both.
You're making the same on both. So you're putting a 2x minus 1?
Negative 2x.
Negative 2x?
And then,
Okay, I see where you're going with this. You're saying now they have a same on both, and you want the lead coefficient ratio to be negative 2, but there's one flaw in your assumption here. You thought that this... No, wait, actually, that could still work. That could work. That could work. There's just another way to do it also. Yours was right. Because you're thinking lead coefficient, and this is going to be the lead coefficient. I take that times that, it's going to be negative 2x squared. That'll work. And there's a last, like I said, there's a lot of ways you could do this. What's another way? I shouldn't say last, because there might be another way after this. Okay, negative 2x squared minus 16. Ooh, so you're going to make it factor even.
Yeah, and over x minus 3x plus.
Holy smokes. Okay, yeah, there's definitely lots of ways to do this. Okay, over, what did you put? And if you really wanted to be fancy pants, you could have multiplied that out and said x squared plus x minus 12. Okay, but anyway, good. You did this with the assumption that the top would be factored into the negative 2 would come out front, right? And then you'd have an x squared minus 4, which would be x plus 4 and an x minus 4. Yeah, that way could work too. I saw another way too. Yes?
I just put a negative 2 in front of the x plus 4, and then I did.
That's probably, just a second, you're right. I just want to tell people, why couldn't you stop right there?
Because the top is.
Yeah, so it would be a bigger on bottom, and then you wouldn't have a y equals 0 asymptote. And you're trying to force this into being same on both, right? So you added a squared somewhere? Where'd you?
Yeah.
Right here? Yeah. Awesome. Now it's the same on both. Same degree on the top and the bottom. And therefore, if it's same on both, it's got to be a ratio of the lead coefficients. And then you threw in this 2 so that your ratio would end up being negative 2. So it would look like that. Or 1 for a lead coefficient there. Very nice. So there's a lot of different ways you could have written that. How many of you would have had it right? One of the ways I showed was your way. Awesome. That's almost everybody. Way to go. Okay. I think now in the next few minutes it would be wise for us to look over the worksheet that we have for our review worksheet. So let's look through a few of those, and I'll tell you which ones I want you to do today. You don't have to do the whole worksheet today. Otherwise, we'd have nothing for you for tomorrow. So we're going to divide it up in 2 parts. I'll pause while we find. Okay, so here we are in 9.7 review, asymptotes and wholes review. Okay, I think we're definitely not throwing out problems, but we are going to be wanting to divide this up. And I think the best plan is instead of doing like first pages the first day and second page the second day, some of each today and some of each kind tomorrow. So I want to divide it up this way. I want you to do 1A, and I want you to weight, or A, C. How about we do the left side of the page, which would be like A but not B, C but not D, E but not F. We'll do the left side of that front page. Will that work here too? Yep. Do the left side. We'll just do the left side of everything, except for 10, 11, and 12, in which case I think we'll have more time to work tomorrow, so I'm just going to assign you 11. So do the left side wherever there's a left and a right side. And when you get to the very end, just do problem 11. Okay? I think that should be a reasonable sized assignment. Now, this is a really critical point. You've got time to work. And if you choose to just like not ask me any questions and fool around during this time, you're wasting an opportunity. If there's anything you don't understand, jump right to that problem. That kind, look through it and go, oh, I don't get that kind. come up and ask me, okay? Because I want to help you during this time. And that's all I have for the video for today. Okay, I'll put on some music and you feel free to